Thank you, Kelly, for that global perspective. And now let's count down launch to Leo and find out about the exciting developments shaping the future of human presence and research in space. After the incredible era of the International Space Station, it is my pleasure to invite astronaut Michael López-Alegría, Chief Astronaut Officer at Axiom Space. Mike has been to space 6 times, out of which he spent 67 hours and 40 minutes spacewalking, holding the NASA records for most spacewalks. Please welcome.
Shalom. It's very good to be with you, and I'm actually kicking off a series of 3 presentations from different companies, all of whom are competing to be the successor to the ISS. But first I want to start out with a little context. The ISS is an amazing platform. I think by now you've heard that as of November of last year, we completed 25 years of continuous human presence, which is a remarkable achievement in and of itself. But to give you this context, why are we going to space in the first place? Why are we going to low Earth orbit? And the reason is because of this. So for all of you engineers and scientists in the room, you can take a nap for the next 30 seconds or so. This is meant for the lawyers and the history majors. There is gravity in space, almost the same gravity as we have here on Earth, but you've seen plenty of pictures of astronauts floating around, and the reason that they do that is because the spacecraft, in this case the space station, is in orbit around the Earth. So it's traveling, it's only at 400 kilometers, which, as I said, means the gravity is about the same as it is here, but we're going very fast. So we're effectively falling around the planet, and that's what provides us the unique opportunity to experiment in microgravity. So when you take away gravity, you see other forces that come to play that are normally sort of overwhelmed by the preponderance of 1G here. Things like surface tension, capillary flow, et cetera. And so for the last 25 years, and even before that on the Mir space station and the other first Soviet and American space stations, Skylab and Salyut, we've been doing experiments. We're trying to understand sort of basically fundamental physics. And I think Kelly's point in the previous briefing was very salient in that when the ISS goes away, a commercial company cannot be sustained just by doing experiments. There's about $400 million in markets around the world per year just on doing science experiments, but that is not enough to sustain a space station. So what we do is we take the things that we have learned and we take them 1 or 2 steps further. And I'm just going to go into one particular thing that we can do as a commercial space station that governments really aren't supposed to do, and that is make money. So these are some examples of products that are in the biological sciences vertical. Things like looking at tumor organoids, how we can perhaps understand a pharmaceutical or therapeutic that works faster because of cell changes in microgravity. So we can advance that to the point where we can bring the idea either to market on Earth or in some cases, in the case, for example, of printing biotissue, and they've already proven this with making retinas in space, that you could do something that you make in space and bring back to Earth. And this is just one example of very many verticals. Take, for example, semiconductor crystals. I think it's obvious that if you build a crystal on Earth, at some point it collapses under its own weight unless you have scaffolding or other very complicated structures. But in microgravity, it just continues to grow. Fiber optic cable, making metals that are, once a metal dissolves and reforms in space after being at high temperature, it ends up being twice as strong as it was in its original form. So these are just some opportunities for companies to be able to manufacture products, services in space that we can't do in 1G. All of that to say, the ISS, after its proud history, at some point must be retired. And the 5 agencies around the world that are part of the partnership So NASA, the European, Japanese, Canadian, and Russian space agencies has said that by 2030 it's going to come down and we need to have a commercial successor. Why? Because those countries still want to continue to send their astronauts there, but more importantly, there is demand beyond just those agencies to other sovereign countries and companies and research institutions. So this is Axiom's solution to it, the Axiom station. Back in 2020, we were awarded an opportunity to attach a module directly to the ISS. Now, this is very advantageous because it's difficult to fit all of the complicated systems into one piece and one launch to get it there. You may know the ISS was put together over many years of many different vehicles taking pieces to it and being assembled modularly. Likewise, we plan to do the same thing. And how we plan to do that is step by step. So the first module is called a payload power and thermal module, and it's just like it sounds. It has solar arrays, it has thermal rejection capability, but it also has accommodations for payloads. And this is important because we can berth it to the ISS and take advantage of the large opening of the hatch and take equipment that will soon not be needed on the ISS, saving us the cost of manufacturing it on the ground and, importantly, lifting it into space. So think about freezers, incubators, furnaces, all of these things which have been done on the ISS can be transferred into the racks on the PPTM. And not long after that, a second module, HAB-1, which has a life support system in it, will launch into the same orbit. The first one will unberth from the ISS and then attach itself. And from that point on, with just two modules, we'll have a fully operating space station. Let me advance this a little bit and show what it'll look like piece by piece. We think the first module will launch in 2028. Our game is to have the two modules together by 2030 to be able to support the retirement of the ISS. The HAB-2 module, which looks a lot like HAB-1, also has berthing for 4 crew members and environmental control and life support system that can support 8 members each, so there's plenty of redundancy there. We have an airlock that will come up to be able to do external EVAs, extravehicular activities, or spacewalks, as you heard. This is not so much important for the maintenance of the space station because most of the components are on the inside, but there's a lot of commercial possibilities doing EVA with customers. So these modules are actually being built today. There's a company in Italy that built about a third of the pressurized volume on the ISS, and they are in fact the ones that are making the HAB-1 and HAB-2 modules as we speak. The idea is that the first one will be finished. The final weld was done a couple of months ago. It's undergoing pressure testing in Italy and will be shipped to Houston, where it'll be integrated with the avionics, the life support systems, the guidance, navigation, and control, propulsion, all the things you need for a space station. And this is a shot of our facility in Houston where that integration will take place. It's not only important to have the software and the hardware of the modules that you've been seeing pictures of, but also to have the team on the ground that can support them. And this is why we undertook private astronaut missions. So in 2022, we flew this mission with your very proud astronaut, Eitan Stibe, as well as Mark Pathy, who was on a previous panel, and Larry Connor, an American. Now, the idea to do these private astronaut missions is not only to open the market, and you'll see toward the later part of the presentation that there are a lot of countries that are interested in going to the ISS that don't really have the opportunity to do that today, but also to prove, to develop and then hone the practices, the people, the organization, indeed the infrastructure to manage a mission from the ground. So we rely quite a bit on NASA during these private astronaut missions when we send our crews up there. But as we do, we are actually growing a team on the ground that is sort of mirrored to see the capabilities that they have, but also to develop our own in-house procedures, because once we have our own space station, we obviously need that kind of capability. Now, these missions look a lot like a normal ISS mission from one of the 5 agencies. We do mostly science, a lot of outreach. We have a lot of research partners. I can show you just a few of them here. On the first mission, Rakia was an amazingly important piece of that, and you have seen, I think, the impact in this country of what that mission has meant. And rather than go through the whole story of the mission itself, I'll just play this quick video, which will give you a good idea of what it was like.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Stop. Go Falcon, go Dragon. Godspeed, Axiom 1.
The key mission objectives for AX-1 have always been scientific research and outreach, performing meaningful science while still taking the time to communicate out the impact and application of that research.
This is really the opening of a new era, where it's not just government astronauts like it's been for the last 60 years.
When you start to dig into it, microgravity is a very unique environment to conduct research and experiments. Just the whole experience looking out of the cupola
is beautiful, amazing, emotional.
אנחנו עפים מעל כדור הארץ במהירות עצומה, וכל 45 דקות יש או זריחה או שקיעה. רואים כדור מדהים.
It's been an amazing experience. This will be something that we can share with humanity.
After 17 total days in space, 15 of them aboard the ISS, we are in the final phase of a journey that has covered more than 240 orbits and 6.3 million miles.
There's our first view of Dragon Endeavour re-entering the Earth's atmosphere with the Axiom 1 crew. We can confirm that the Dragon capsule has splashed down.
To the crew of AX-1, well done.
I have to say that was a lot of fun. But we didn't stop there. We did actually one in 22, 23, 24, and just last year in 25. In total, we have flown 12 customers from 11 different countries, over 100 experiments, dozens of outreach events, and importantly, as I mentioned before, you see all the flags. These represent a lot of countries that don't have access to the ISS. On the last mission, we had an Indian, a Pole, and a Hungarian. They were each the second person from their country to fly, the first in a generation, obviously the first to the ISS. On the one before that, we had the first Turkish human to go to space. So we are not only building the team on the ground to manage the space station that we will succeed the ISS with, but also we are opening frontiers to people who until now have not had the opportunity. I'm very optimistic about the future of commercial space stations. I think in the future we will have at least one in orbit, if not more. The phrase that we like to use is building an economy in low Earth orbit. It is not routine by any means to get there, but we've been doing it for over 60 years now. We know how to do it. We can do it relatively safely and with a certain cadence. And that's going to permit us to make the low Earth orbit a place that isn't just to visit for professionals anymore, but also for people from around the world, different countries, different backgrounds, and different interests. Thank you very much.